Our topic is half range series. What we did earlier, we expanded any function in the range from 0 to 2 pi as well as from minus pi to plus pi, right? Also, we expanded any Fourier series in the interval from 0 to 2L as well as from minus L to plus L, right? This we did in our previous lectures. Now, in today's lecture, we are going to deal with half range series. Half range name itself implies that range will be half. That means instead of 0 to 2 pi, we will deal with the series within the range 0 to pi. Sometimes it is required for the function to expand that function in the range in the half range, which is 0 to pi. And similarly for 0 to 2L, it will be from 0 to L. So we are going to do half range series from 0 to pi and from 0 to L, right? Now half range series is of two types. One is cosine series and another is sine series. So we will divide under 0 to 2 pi. We will make two categories, half range sine series, half range cosine series. Similarly, under the category 0 to L, we will divide it into two parts, half range cosine series and half range sine series. Because sometimes it is required to expand any function in the half range. So that's why we are going to do this. So, firstly, let's consider the limit 0 to pi, right? Now, number one, half range cosine series is given by, now see, earlier when we had the complete limit from 0 to pi, earlier in previous lectures, when we talk about 0 to pi, what was the Fourier series? It was fx is equal to a naught by 2 plus summation an cos nx plus summation bn sin nx. This was a complete Fourier series where we had the formulas of a naught, an and bn, which are called Euler formulas, right? Now, since we need to write down only, firstly the word is half range. Half means 0 to pi. And then the word is cosine series. That means series which will contain only cos terms. That means it will not contain sine. That's it. That means this one. So, half range cosine series is given by fx is equal to a naught by 2, constant comes under cosine series, plus summation an cos nx, where n varies from 1 to infinity. So, this is our half range cosine series. It will not contain the terms of sine, where a naught is same as we did earlier, 1 by pi, 0 to pi, fx dx, and similarly an is equal to 1 by pi, we have 2 by pi, 2 by pi, 0 to pi, fx we will not check even odd here. It is by default that we have 2 by pi, 0 to pi fx dx, similarly 2 by pi, 0 to pi fx cos nx dx. So this is about half range cosine series, and similarly half range sine series. Now, the name itself implies firstly the range is half, 0 to pi, and now we are going to talk about sine series. Sine series will contain this one, Bn. That means fx is equal to summation Bn sine nx. When n varies from 1 to infinity, that means we need to find only one value whenever we have to find half in sine series, where Bn is given by 2 by pi, 0 to pi fx into sine nx dx. Here, in the same way, we can expand the Fourier series in the interval where limit is constant. That means from 0 to n, half range. So, firstly we can write down half range cosine series is given by fx, same series will continue a naught by 2 as summation an. But when we have the constant limit, what we write down? Instead of cos nx, what we write? Cos n pi x upon n, where n varies from 1 to infinity. Further, a naught is given by 2 by n, 0 to n, fx dx, and an is 2 by l, 0 to l, fx into cos n pi x upon l dx, right? And one more, second, earlier it was half range cosine series. Now we are going to write down half range. Name itself implies half range, but sine series. Now sine series will give you only the function in terms of sine. It will not contain cosine terms. So fx is equal to summation bn sine n pi x by n, where n varies from 1 to infinity. And further, bn is given by 2 by l, 0 to l, fx into sine n pi x upon l dx. Right? This is so we will be given the range. Either it will be from 0 to pi or it will be from 0 to l. And these are the basic results.